Thank you, John. So now, after we have seen the Juju introduction, now we come to a very fundamental part of integrating services together. Let's see how we can enable encrypted HTTPS communication between the different components. So see our colleague, Ghislain, explaining how a software operator makes certificate management much easier. Thank you. Go ahead, Ghislain.
Thank you, Cedric. Hello, everyone. My name is Ghislain Bourgeois. I'm a senior engineer at Canonical in the Telco Charm engineering team. And I'm here today to talk to you about Let's Encrypt certificates and the Juju operator ecosystem. So the agenda for today is, first we'll be talking about getting TLS certificates in your charms. How can you do that? Why would you want to do that? Then we will talk about using TLS certificates operator to get self-signed certificates. Then we'll go on to talk about Let's Encrypt the Acme protocol and challenges. And we will then replace TLS certificates operator with Route 53 Acme operator. And we will talk finally about supporting other DNS providers. First, let's talk about getting TLS certificates in your charms. But first, why would you want to get TLS certificates for your workloads? Let's face it, it's 2023. Security is of the utmost importance, and using cryptographic certificates is an important part of a secure infrastructure. It is also often required by laws and regulations and is the right thing to do anyway. In the telco engineering team, we created the TLS certificates interface to integrate charms requiring certificates with charms providing them. It comes with a library that provides the tools to request certificates, and it provides custom events when a requested certificates becomes available on expiry and on revocation. It's easy to get the library using this charmcraft command. And now we can take a look at an example of how to implement this in a charm. So this is the example charm that we will be using during this talk. It's a small Nginx operator that's not doing much. So this is the commit that added the support for TLS certificates interface. So the first thing we need to do is to go into the charmcraft.yaml file, and in the parts, add some build packages that are required for cryptography and also charm Python packages that are required to build the dependencies. Then in the config.yaml, I added the configuration item fqdn for the fully qualified domain name of the server that will be required when we request a certificate. We have also the library that we integrated into our charm. And in the metadata, we add a requires interface using TLS certificates. In the requirements, we add JSON schema and cryptography that are dependencies for the library. And in the charm, we import the TLS certificates require v2 to a helpful method to generate CSRs and private key. Some other status, and we interaction with instance, we added a config certificates relation join, certificate available, certificate expiring, certificate invalidated, and all certificates invalidated. Most of those are only treated by the same method. So in the case of config change and certificate relation change, we will talk to request certificate. On certificate available, we will use on certificate available. And for all the certificate expiring or invalidated, we will request a certificate renewal. So Pebble Ready is not that interesting. We added some restart to Nginx for when we reconfigure it. In request certificates, so when a configuration change happens or we get related to this certificates interface and we have a provider we will call this event. We will first have a few guard clauses that will make sure that we can proceed. And after that, we will make sure that we have a private key, generate a private key using the provided method from the TLS certificates interface library. We will use that private key to create a CSR with the subject of our fully qualified domain name. And we will send this CSR here. The line numbering is weird with this zoom level, but we request the certificate creation to the library by sending the CSR to the library. And then we wait for the requested certificate to become available. Similarly, when we want to have a new certificate, a certificate renewal, we will basically take the old certificate, take our private key and generate a new CSR, and we will update the certificate by requesting a certificate renewal, passing the old CSR and the new CSR to the library. And again, we will be waiting for the requested certificate. When we get a certificate available in the relation, we will first have the same guard clauses that we used before, and then we will take inside the event there is a certificate. We will push that to our container. We will also push a TLS config for Nginx. In our case, we're just adding a small configuration to Nginx to enable SSL with the certificates that we push to the containers. And then we will call again Nginx Bevel ready to make sure that we restart Nginx to load the new configs. So generation of the private key is done with the generate private key function that we imported from the library. We push it to the container as the key, and we put it in a pure relation in this case. We have the FQDN property loading the configuration from our model, and we push the TLS configuration with this. And the TLS configuration is just Nginx configuration saying to use port 443 and use the certificates that we put in place. So with that, we can go back to our presentation. We will now go through a demo with our example charm, integrating it with the simplest provider, the TLS certificates operator. This operator is designed to provide either self-signed certificates or hard-coded certificates provided by an administrator. So let's start with those commands. We will go here. We will first start by adding our model. Now we will be able to watch the status. Then we will deploy our demo charm. I'm using a local charm since it's not published on Charm Hub, so I need to also specify the image I'm using, and I'm passing the config of the FQDN. So this will take a little bit to upload the charm and get deployed. And now we will get the services in the operator namespace, because we created oh, I forgot to. Forgot an important part of the command. Sorry about that. I need to deploy this charm with trust, because it needs to patch a Kubernetes service. Otherwise, we won't be able to connect it to the outside world. So let me just add that here. Okay, and now it says it's waiting for a certificate relation to be created, but we can already see that we have a load balancer service. This is a load balancer in AWS. We will copy this and we'll go to our AWS Route 53 hosted zone, and we'll create a new record. We will create a CNAME record. In this case, we will use Nginx to have like our FQDN that we configured. We will paste this load balancer address and create the record. So at this point, we should be able to go to this website as an HTTP website. So we see that the connection is not secure. It's only using HTTP, but we will then go to our TLS certificates operator to create, to get a certificate. So the next step is to deploy the TLS certificates operator and relate it to our Nginx operator. So we will deploy TLS certificate operator using a common name for the CA, and we also pass a config to generate self-signed certificates. And then we can relate Nginx to TLS certificates operator. We see that it's executing and configuring Nginx server service. So we can go back to here, and we should be able now to connect over HTTPS. I'm not sure why it's saying that. It should not. Okay. Some problem with my cache. So connection not secure. Of course, it's not secure because the certificate has an unknown issuer. We can see that the common name of the issuer is myfigCA. So this is sometimes good enough in testing environments and things like that, but in public it's not really great. So we can definitely do better than that. So this brings us to Let's Encrypt, the Acme protocol and challenges. So Let's Encrypt is a free public certificate authority trusted by the world. It provides certificates through an automated process following the Acme protocol defined in RFC 8555. This means that any other CA can provide automated certificates through the same standard automated process. So when a certificate is requested, the CA's job is to validate the identity, the ownership of the domain that's requested. The protocol, the Acme protocol, uses challenges for that purpose. There are two main challenges that are used in the wild. So there is HTTP 01 that provides a challenge value and nouns to sign and put on your web server, and Let's Encrypt can then look at that well-known location and read it. And for that, you require your web server to listen on port 80 and be able to put something in that well-known location. And there's a DNS01 challenge that basically does the same thing, but you put the challenge response in a TXT record on your DNS provider. The HTTP01 challenge is usually used when you control directly the workload, but it does not work in our case since we want to have a separate charm that handles this communication. So we will use the DNS01 challenge. The DNS01 challenge also has some advantages like supporting wildcard certificates, and it also supports getting certificates for servers that might not be publicly accessible. So you could have only your DNS accessible and the server you're requesting a certificate for is behind your firewalls and not accessible. Oops. Not sure why it got out of full screen. Let's continue. So the TLS certificates interface is used between our Nginx operator here and Route 53 Acme operator that we will use in this demo. Then the Route 53 Acme operator will be handling the communication with Let's Encrypt and with Route 53. So Let's Encrypt will provide a DNS01 challenge, and our Acme operator will update Route 53 with the challenge response that will let Let's Encrypt validate that we actually own this domain. So now we are ready to replace our TLS certificates operator with the Route 53 Acme operator. So first of all, we need to create a YAML configuration file for the Route 53 Acme operator. It starts with email and server. Those two are required for all the Acme operators that are built with the base Acme client that we'll discuss later. This is required for pretty much everything, every client's by the protocol. And then we provide some AWS secrets, zone IDs that are required by the DNS plugin. And now we're ready to run the different commands. So we'll remove the TLS certificates operator, deploy our new Route 53 Acme operator with our config, and relate them. Not this one. Okay, so while this is deploying, we can already relate our Nginx operator to our Route 53 Acme operator. And now we can see that the Route 53 Acme operator is executing, and it's executing the Lego command. So underneath in the backend, we use Lego, which is a Golang implementation of the Acme client. So it's executing the command, and it's taking longer than with the TLS certificates operator because we need to talk to Let's Encrypt to request a certificate, then talk to Route 53, and then wait for DNS propagations to happen for Let's Encrypt to be able to validate that we actually own this domain. So this shouldn't take much longer to get our certificates. So anytime now we should go into active idle and be able to validate that this has worked in the browser. Okay, so we see that Nginx operator is configuring Nginx, and now we should have our certificates. So we can refresh this here. And now we have a connection secure verified by Let's Encrypt. We can take a look at the certificate, and we see that it's for us, it's validated by Let's Encrypt, and it just got issued. So this has worked perfectly. So that was all great for a demo, but what happens if your DNS provider is not Route 53? So we thought of that, and we decided to create an easy way to support additional DNS providers. So you can already find on CharmHub the Route 53 charm and also a charm for Namecheap. And under the hood, like we said, we are using the Lego Acme client implemented in Golang, and it provides over 100 different DNS provider plugins. So your DNS provider is probably already supported. So we created an abstract-based charm to make it easy to create an additional DNS provider Acme charm. So let's look first at the at the metadata.yaml. So we create our metadata. We create a provides certificates with the TLS certificates interface, and we use the Lego image as an OCI image. Here's our config. So as I said, email and server are required for all Acme clients, and DigitalOcean in this case is using only one variable, the DigitalOcean auth token. And here is the entire code to implement a minimal charm to implement this for DigitalOcean. So first of all, observe, we call super with the plugin name DigitalOcean, and we observe only config change. On config change, we validate our own config, then we dispatch to the super class to validate the generic Acme config, and we go to active status. The only other thing to do is to provide this plugin config property that returns a dictionary of variables, all in caps, with the value of the variables, and we already have our DigitalOcean Acme charm ready to go, and it fits on a slide. So thank you everybody for listening to my talk. If you have any questions, you can ask them in the chat. I will be there. You can also contact me directly on Charm of Mattermost in Discourse with my nickname here. Here are some links for the charm that we used in this demo, and also a link to an announcement on Discourse that goes into some details about what we talked today. So with that, enjoy the rest of the day, and I will give back the floor to Cedric.